Hello friends, myself B Shalini. Today I am going to discuss about the sulfur cycle. So first, what is the sulfur cycle? The sulfur cycle is a biogeochemical cycle in which the sulfur moves between rocks, waterways and living system. It is important in geology as it affects many minerals and in life because sulfur is an essential element being a constituent of many proteins and cofactors, and sulfur compounds can be used as oxidants or reductants in microbial respiration also. Global sulfur cycle involves the transformation of sulfur species through different oxidation states which play an important role in both geological and biological processes. Now coming to the steps of sulfur cycle, there are mainly four basic steps of sulfur cycle. These are: the first step includes the mineralization of organic sulfur into inorganic forms such as hydrogen sulfide, elemental sulfur and sulfide minerals. The second step is oxidation of hydrogen sulfide, sulfide minerals and elemental sulfur to sulfates. The third step is the reduction of sulfate to sulfide. And the last and fourth step is the incorporation of sulfide into organic compounds, including metal containing derivatives. Now, let's see what are the sulfur sources and sinks. The sulfur is generally found in oxidation state ranging from +6 in sulfates to -2 in sulfides. Thus, elemental sulfur can either give or receive electrons depending on its environment. Generally, on Earth, the maximum sulfur is present in minerals such as pyrites, that is FeS2. The amount of mobile sulfur increases through volcanic activity and by weathering of crust in an oxygenated atmosphere. The Earth's main sulfur sink is the ocean's sulfates, where it is the major oxidizing agent. The amount of sulfate in oceans is controlled by three major processes. That is, they are input from rivers, second one is sulfate reduction and sulfide reoxidation on continental shelves and slopes, and the third one is burial of anhydrite and pyrite in oceanic crust. Now let's see how this sulfur cycle works in nature. The mechanism of working of sulfur cycle is as follows. First, the sulfur is released by the weathering of rocks. This sulfur comes in contact with air and is converted into sulfates. Now, this sulfate is taken up by the plants and microbes and are converted into organic forms. This organic forms of sulfur is then consumed by animals through their food, and thus sulfur moves into the food chain. When these animals die, some of the sulfur is released by the decomposition, while some enter the tissues of the microbes. There are several natural sources of sulfur, such as the volcanic eruptions, evaporation of water, and breakdown of organic matter in swamps that release sulfur directly into the atmosphere. This sulfur falls on the earth with rainfall as sulfuric acid. Now let us see what are the sources of marine sulfur cycle. Generally, the riverine sulfate derived from terrestrial weathering of sulfide minerals is the primary input of sulfur to the oceans. Other sources are metamorphic and volcanic degassing and hydrothermal activity, which release reduced sulfur species. There are two major outputs of sulfur from the oceans. The first sink is the burial of sulfate either as marine evaporites or carbonate associated sulfates. And the second sulfur sink is pyrite burial in shelf sediments or deep sea floor sediments. This was about the sulfur cycle and its steps. Now coming to its economic importance. Sulfur is involved in the production of fossil fuels and a majority of metal deposits because of its ability to act as an oxidizing or reducing agent. Vast majority of major mineral deposits on earth contains sulfur. Iron sulfides, then galena and sphalerite form as byproduct of hydrogen sulfide generation as long as the respective transition or base metals are present or transported to a sulfate reduction site. Sulfur also acts as reducing agent in many natural gas reservoirs, and generally the overforming fluids have a close relationship with ancient hydrocarbon seeps or vents. The presence or absence of sulfur is one of the limiting factors on both the concentration of precious metals and its precipitation from solution. The pH, temperature, and redox states determine whether the sulfide will precipitate or not. The overfluids are linked to metal rich water that have been treated within a sedimentary basin. Generally, the redox conditions of basin lithologies exert an important control on the redox state of metal transporting fluids. The bacterial reduction of seawater sulfates is an important source of sulfide. Once these fossil fuels or precious metals are discovered and either burned or milled, sulfur becomes a waste product. There has been an increase in the amount of sulfur in our present atmosphere because of the burning of fossil fuels. Now, the sulfur acts as an pollutant and an economic resource at the same time. Now, coming to its human impact, the human activities have a major effect on the global sulfur cycle. The burning of coal, natural gas, and other fossil fuels have greatly increased the amount of sulfur in atmosphere and ocean and depleted the sedimentary rock sink as a result. Without human impact, sulfur would have stayed tied up in rocks for millions of years and it have always present as unused thing. The human activities generally don't cause a major change in the global pools of sulfur, but they do produce marine changes in the annual flux of sulfur through the atmosphere. When the sulfur dioxide, that is SO2, is emitted as an air pollutant, it forms sulfuric acid through the reaction with water in atmosphere. Once the acid completely is dissociated in the water, it causes damage to both man-made and natural systems. Acid rain, we all have already studied it, is a mixture of wet and dry deposition containing nitric acid and sulfuric acid. As it is an important nutrient for plants, sulfur is increasingly used as a component of fertilizers. Recently, sulfur deficiency has become widespread in many countries of Europe. Because of actions taken to limit the acid rain, atmospheric inputs of sulfur continue to decrease continuously. So, as a result, the deficit in the sulfur input is likely to increase unless the sulfur fertilizers are used. Let's study what are the threats caused by anthropogenic activities. Some of the examples of anthropogenic or human activities performed which degrade the environment are the human mining, that is the mining of coals or mining of heavy metals, then the release of industrial waste including heavy metals like mercury, arsenic, cadmium, which generally pollute the environment and due to which the plants die. And the third one is smelting of arsenic ore, then incineration of fossil fuels, especially the coal, then the utilization of arsenic loaded water for irrigation. Through water also plants can be loaded with arsenic. These plants are taken up by animals and these animals are in turn taken up by humans. So the concentration of arsenic or heavy metals, they keep on increasing and they get at its highest level in humans. So the biological magnification can be studied in this process. And the utilization of arsenic based pesticides, herbicides, and fertilizers also degrade the environment. The sum of the effects of the anthropogenic activities are destruction of ecosystems, then habitat destruction, and depletion of reservoirs and resources like air, water, and soil, extension of wildlife, and the ultimate one is causing the pollution of different resources, including land, water, soil, etc. So this was about the sulfur cycle and the how the human activities are depleting the sulfur cycle and destroying the environment. I hope you have all understood it. Thank you.